So today we're going to talk about solving equations, and we're going to start with some that should be familiar to you from Algebra 1. And we're also going to talk about equations today and this can happen, that either have no solution and how to figure out if that's the case, or they have infinitely many solutions, and we'll learn how to figure out if that's the case. So let's go ahead on page 9 of our notes. We're going to go to example A. And we have an equation where we have the variable on both sides. And remember, these were kind of the harder problems in Algebra 1, but these are the easier problems in Algebra 2. And remember that the goal of this is we want to get all of our variables on one side. And to be honest with you, it does not matter which side we put them on. So it's possible for you and your neighbor to do a problem using different steps and still arrive at the same answer. All right, so what I'm going to do first is I wanted to get all of my t's on one side. Me personally, I like to put my t's on the side where I can make them positive. So what I'm going to do is subtract 5t on both sides. And that way, these 5t's will cancel out, and I have 8t minus 5t leaves me with 3t plus 17 equals 35. At this point, I have a simple two-step equation. I'm going to go ahead and subtract 17 from both sides. And I think that gives me 3t. I'm going to try and do math in my head. This is 18, right? And divide both sides by 3. And we get t equals 6. So if we go and look at example B, we have variables on both sides of this equation, but we've got it a few times. Here's some x, and here's some x over here. Here's what I recommend that you do. Do you see how on the right-hand side we have x and 8x? First step should be combine like terms and make that be 9x, because x plus 8x is 9x. So I have on the left-hand side a 5 and a negative 18. Those are like terms. So I'm going to combine like terms on that side. So this side will have negative 3x. 5 and negative 18 is minus 13. Over here, x and 8x gives me 9x. And then I have minus 1. And like I said in the last problem, I like to move my x's to the side where x will be positive. So what I'm going to do is I'm going to take my negative 3x over here, and I'm going to add 3x to both sides. And when I do that, the 3x's are going to cancel over here, and I have negative 13 equals 12x minus 1. And I will tell you, let's go ahead and circle this in our notes, because this is actually one of the most common mistakes, is not to bring the negative that's in front of this 13 down to the next step. That's one of the most common algebra mistakes. So at this point, I want to get my variable by itself, so I'm going to get rid of the 1. So I'm going to go ahead and add 1 on both sides. And this is going to give me negative 12 equals 12x. Divide both sides by 12. And I have x equals negative 1. All right. To save a little bit of time, I'm going to go ahead and skip here to example D. So example C and D are similar, but D is a little bit harder. So I'm going to go with example D. You can see it looks like distribution should happen, right? It should. So the very first thing we're going to do is go ahead and distribute. And right here it seems pretty easy to do that, but let me point out to you what is a really common algebra mistake. When doing this distribution, you are not distributing a 2. You are actually distributing a negative 2. You need to take that negative sign with it into your distribution. So right here, 3 times 2x gives me 6x. 3 times negative 1 gives me negative 3, so minus 3. Negative 2 times 3x is negative 6x, so minus 6x. And negative 2 times 4 gives me negative 8, so minus 8. And that is going to equal 11x. So notice I've got some like terms on the left-hand side of this equation, and what I'm going to do is go ahead and combine my like terms. Now you may have noticed here that I have plus 6x and minus 6x, and yes, those do cancel each other out to 0. And so I have negative 3 and negative 8 gives me negative 11 equals 11x. Divide both sides by 11, and I have x equals negative 1. We're going to kind of gloss over the fraction problems for right now, because I do not think that any of the problems that you have tonight have fractions in them, and we're going to save these for tomorrow, because I think all your homework tomorrow is fraction problems, so we're going to hit that hard tomorrow. So come back to tomorrow's video for fraction problems, and what I want to do is go to the next page, and we're going to go down here to example 4, where we have equations with no solution and what is called an identity. And it says, is the equation always, sometimes, or never true? Well, the way to answer that is to first solve the equation, and we're going to use the same skills that we just used to solve equations on the prior page. So right here, notice I have some like terms on the left, and I have some like terms on the right, and I'm going to go ahead and combine like terms. So I have 7x and negative 4x gives me 3x plus 6. Over here, I've got 12 and negative 8, and that's going to give me a positive 4 plus 3x. Now I want to get all my x on one side of the equation, so maybe I'll subtract 3x from both sides. And an interesting thing has occurred here, because you can see my 3x's cancel here, but they also cancel here. And what I'm left with is 6 equals 4. Now let me ask you, does 6 equal 4?
No.
No, 6 does not equal 4. And so here's what the situation is. This is a situation where there is no solution. And so this equation, we would say, is never true, because there is no instance where I can ever make this equation work. So this is a never situation. Now, on the previous page, we got an answer for each of those problems, right? Those would be examples where the equation is sometimes true. So on example B, I think our answer was negative 1. Well, when our variable is negative 1, it's true, and when it's anything else, it's not, so it's called sometimes true. All right? So let's go ahead and we'll do the next example and see how this one comes out. So we're going to go ahead on the left-hand side, and we're going to distribute here, and on the right-hand side, we're going to distribute here. So I've got 2x, I've got 3 times x gives me 3x, and 3 times negative 4 is minus 12. And over here on this side, I have 2 times 2x is 4x, 2 times negative 6 is minus 12, and then I've got a plus x. So all I've done is distribute so far. And the next thing I'm going to do is combine my like terms. So when I combine like terms here, I have 2x plus 3x gives me 5x minus 12. And over here, 4x plus x gives me 5x, and I have minus 12. Now, do you see something unique about this particular situation? Both sides are identical, aren't they? This is what's called an identity. All right, so I'm going to write that over here. This is an identity. Now, would you agree? I can take a look at this equation, and no matter what value I put in for x, this is going to work, right? If I put in a 1 for x, what's on the left side is going to equal what's on the right side, isn't it?
Yes.
If I put 1,000 in for x, what's on the left side is going to equal what's on the right side, right? Exactly. All right, so this is what we call always true. But what I want to do is continue with this to show you, if you don't see this at this point, what you do next. So if you have this situation, but you don't notice that you have it, go ahead and subtract your 5x on both sides. And the 5x's cancel and cancel. Bring down your negative 12 equals Negative 12. Now, is that the case? Does negative 12 equal negative 12? Yes, it does. So guess what? No matter what I put in here for x, this is going to work. And we say that our solution is all real numbers. Now, sometimes when you see me writing this out, I abbreviate all real numbers, and you may see it abbreviated in something you're looking at. It's usually a script ER. This is just my script ER, what it looks like. I got a beautiful stem on my script ER, but that's my script ER. It stands for all real numbers. Phoebe, you have a question?
Yeah. Can you add 12 to both sides and get 5x equals 5x? Is that the same?
Okay, and the question is, what are you going to do once you get 5x equals 5x if you add 12 to both sides? Then what do you do? And I usually will tell you there's nothing wrong with doing that, but the issue is, what do you do next if you don't realize that what you have is an identity and that all real numbers is the solution? Because what ends up happening is people get stuck at that point. So that's why I always say, move your x's first, and once you're rid of them, you have something where you're like, I know what to do with that. So it's not incorrect, but people tend to get stuck in that position when they get 5x equals 5x. All right, so go to the next page, and we're going to go over a couple of examples. And what we're doing with these examples is we are using the same skills that we used for solving equations, but what we're going to do is take a formula that has multiple variables in it, and we're going to rewrite it. So instead of being C equals, we're going to rewrite it with F equals. And instead of being A equals, we're going to rewrite it as H equals. So we're going to flip the formula around so it's a formula for a different thing. This is a really handy skill to have. So we're still going to use the same skills that we used before. So let me show you a real nice way to do this one. And this will come up for you repeatedly. This is the formula to convert degrees Fahrenheit to degrees Celsius, okay? So what we're going to do is switch it around so that we can make it into a formula for degrees Fahrenheit, okay? And there are multiple ways you can do this, and there are multiple correct, and I will put it to you this way. Correct answers can be written in multiple ways. So if yours comes out a little bit different than your neighbor, it doesn't mean that one of you is wrong, because these can come out looking different but still equaling the same exact thing. So what I'm going to do to make this one real nice here is I am going to multiply both sides of this equation by 9 over 5. So 9 over 5 right here, and 9 over 5 right here. It's just a nice, pretty way to do this. And would you agree, what happens here is these cancel to 1. Because any number times its reciprocal gives you 1. So now what I have here is 9/5 C equals F minus 32. All right, would you agree? If I want to get F by itself, the next thing I need to do is add 32 to both sides. And what I've got in the end is F equals 9/5 C plus 32. All right, let me give you example B. So this is the formula for the area of a triangle, and this is area of a triangle is 1/2 times base times height. What we are going to do is rearrange it so it becomes a formula for height. All right, so first thing, when I look at this, height is the thing I want. Would you agree? I want that by itself. So what I want to do is undo all the rest of the stuff that's on the same side with height. One of the ways to get rid of this 1/2 is multiply by 2. So I'm going to multiply by 2 on both sides. Okay? Multiplying by 2 is going to give me 2A equals. Now would you agree? Reciprocal, so that equals 1. And this equals BH. How do I get rid of the b? I want the h by itself.
You divide b.
Divide by b. So I'm going to divide by b here, divide by b here. B's cancel, and I have h equals 2a over b. And it should look nice and pretty like that. Please do not do this. So let's put a little do not do, okay? And we have a equals 1/2 base times height. Do not do this. I do not want to see that. That is atrocious algebra. While it is not incorrect, it looks awful. And if I ask you to use that formula to do something in class, you would hate that formula because you've got a fraction sitting in the denominator. Do not do that to yourself. So I'm going to put a big circle around this and put an X through it. Don't do that. So when you have a fraction, use that reciprocal or at least the denominator to get rid of it.